Okay, good afternoon, everyone. My name is Pawan Gupta. I work with USRA at NASA Goddard Space Flight Center in Washington, D.C. Today, I'm going to talk about how we can use the low-cost air quality sensors operated by the citizen scientist and how we integrate it with the NASA satellite data to improve the value of satellite data. So, as you know, that air pollution is one of the biggest environmental risks in today's world. Almost 5 million people can be attributed die due to air pollution all around the world according to the recent studies. So what we are trying to do here is, if you look the map of global locations where air quality is measured from the ground and the data is available in public domain, open data source, what you see in this map is huge gap in monitoring of air pollution all around the world, specifically in the developing countries where the pollution problem is a huge issue. So what we are trying to do is these low cost new emerging networks of sensor which are really very inexpensive and people can actually operate that from their home office or a school, although they do not, okay, this that's fine, although they do not provide as good quality of the data as these standard instruments, but they, you can deploy them in the large number, and the idea is not to replace these measurement but to complement these measurement and fill some of those gaps in areas where we do not have any measurements. So this is a new emerging network. It's called Purple Air Network. They have almost thousands instruments operated mostly in the US, but slowly it's extending in the all other parts of the world. Next. Okay, so the idea here is how we can integrate this data with the satellite data so that we can actually improve the value of the satellite data and use it in places where we do not have any ground-based measurements. So what you see here in this movie is aerosol measurement, the particle measurement from a sensors called MODIS, and this is a movie showing 1 month worth of the data from that instruments. And as every day satellite is overpassing over different location, it start making measurement under cloud-free conditions. And once about in few days you will see the entire globe is filled up, and then if you do the monthly average, then you will see a nice global map of air pollution all around the world. Now the challenge is this the quantity which satellite is making measurement is the same as what we are interested as to make measurement of the nose level pollution. So there is a difference between these two quantity. What satellite make measurement is the column integrated value of all the particles in the entire column of the atmosphere, whereas what surface measurement or the air quality measurements are making these point measurement, those are nose level air pollution. So there is a difference between what satellite makes measurement and what air quality community is interested. So what we are trying to do in this project is trying to understand the relationship between the two and develop methodologies which can convert that column value to the surface values. Okay. To address this, we have a very project called Citizen Science Project, which employ citizens all around. Right now, we are deploying in the Los Angeles Basin area, where we have recruited 40 citizen scientists, and they will actually deploy these sensors. And the objective is actually to evaluate the quality of this sensor and then how we can integrate this. So this project involves the evaluation of those sensors as well as how we can integrate with the satellite data. So I'm going to show a quickly case study from the California recent fires, which happened since last October and which did impact air quality in that region, and how that the citizen scientists were able to make measurement of that fire. So on the visual image, if you see, this is October 8, October 9, when the fire started, you see a lot of smoke coming up. So this is just one way to look the fires from the satellite. The another way to look at the nighttime imageries, and you can see that actually there's a lot of lights coming out from this fire, which is visible in the satellite imagery. So that's another way to look those fires from the satellite. There's a fire detection algorithm. You can see on October 8, the red dot lot shows actually the fire activities. October 9, the enhanced lot, which was not possible. And finally, you have to quantify how much the smoke is emitting from these fires. And to quantify, we use a quantity called aerosol optical depth, which is a column value. And you can see the huge value, the quantity is very high when the fire was burning and the smoke was emitting from those fires. And the last slide I want to show is here how the satellite is responding to this fire. So this is Bay Area, and all these locations are the citizen science sensors sitting on the ground on the people's house or office, and they are making measurements. So this site is the satellite measurement, and this site is the surface measurement. And what you see here is that this is the day number, which is changing in October. So let it run once. So once the fire start on October 8, October 9, and you will start seeing that the both satellite and surface start responding to those fire. And this way, actually, we can quantify the impact of fire. So you will see this is October 7, this is October 8, and then October 9, as soon as fire started, you can see both satellite and surface are really responding very well to the fires. So with that, that's all I have. Thank you.